What if humanity's greatest discovery isn't on a planet light years away, but right here in our backyard? Orbiting the giant Jupiter, there's a moon that might be keeping a monumental secret. Beneath a seemingly infinite layer of ice, Europa hides a global ocean, deep and completely dark. But what's making scientists' hair stand on end isn't just the ocean. Recent signals indicate it's not sitting still. Something, or someone, is moving down there. A secret that, if real, will turn everything we think we know about life upside down. Looking from afar, Europa seems like just another ball of ice in space. A bit smaller than our moon, its surface is one of the smoothest in the entire solar system. But this calmness is cut by a chaotic web of cracks and red streaks, almost like scars, as if something were pushing the ice from beneath. On the surface, the temperature is soul-freezing, reaching -260 degrees Fahrenheit, a place where, at first glance, life would be impossible. But appearances deceive. For decades, scientists suspected Europa. Confirmation came with NASA's Galileo probe in the 90s. Every time the probe passed near the moon, it detected an anomaly in Jupiter's magnetic field. There was only one explanation that made sense. There was something electrically conductive under the ice. And the best candidate for that? An ocean of salt water. It took time for the pieces to fall into place. Beneath miles of ice, there's an ocean that covers the entire moon, and we're not talking about a little water. NASA estimates that Europa's ocean has more than double the water of all Earth's oceans combined. Think about that for a second. A world smaller than our moon, with a volume of water that makes our oceans look like puddles. But how does all that water stay liquid so far from the sun? The answer is Jupiter's brute force. The giant planet's insane gravity stretches and squeezes Europa constantly. It's a true cosmic tug-of-war that generates so much friction and heat inside the moon that it manages to keep this entire ocean in liquid state. Europa doesn't need the sun. It has its own engine, a heart that beats to Jupiter's rhythm. Okay, but just water isn't enough for life as we know it. The cosmic recipe seems to have three basic ingredients: liquid water, the right chemical elements, and an energy source. And Europa seems to have everything on the menu. Water? Checked, and with plenty to spare. The second ingredient: chemistry. Life on Earth is carbon-based. In Europa, we believe these building blocks of life arrived via cosmic delivery, through comets and asteroids that bombarded the moon for billions of years. And recently, the James Webb Telescope took a peek and confirmed there's carbon dioxide on the surface. And most importantly, everything indicates this carbon came from within, from the ocean itself. It's proof that Europa's ocean isn't a stagnant pool, but a chemically alive environment. Besides carbon, we know the ocean is salty, maybe with good old sodium chloride, our table salt. This not only makes it more similar to our oceans, but also means there's a lot of interaction between the water and the moon's rocky bottom. And this brings us to the final ingredient, the game changer: energy. Far from the sun, life needs to find a way to get energy. And this is where the mystery gets even more interesting. That same heat generated by Jupiter can do more than just melt ice. It could be feeding volcanoes at the ocean's bottom. Just imagine, an ocean floor full of hydrothermal vents, cracks that spew super hot water loaded with minerals and chemicals from the moon's interior. Each of these vents would be an oasis of energy, a chemical feast for life in total darkness. Life thriving in complete darkness sounds like science fiction, right? Wrong. We have a perfect example right here on Earth. In the depths of our oceans, where sunlight doesn't even dream of reaching, there are entire ecosystems that live around hydrothermal vents. They're dark chimneys that spit out a super hot chemical soup, poisonous to most living beings. But there, life doesn't just exist, it thrives. Bacteria and other ancient microbes use a trick called chemosynthesis. Instead of sunlight, they eat the chemical compounds that come out of the vents, like sulfur, and transform that into energy. These microbes are the base of an entire food chain that supports giant worms, crabs, and other bizarre creatures that have never seen daylight. They're living proof that life only needs water and a chemical energy source. So when scientists look at Europa, they see a reflection of these deep-sea oases on Earth. The conditions we imagine exist at the bottom of Europa's ocean are practically a mirror of our hydrothermal vents. Rocky seafloor, liquid water, heat and chemistry coming from within. If life managed to arise in such an extreme environment here, why not there? The question that keeps scientists awake at night isn't whether life can exist in Europa, but how it could not have emerged with all the ingredients on the table. And now we return to that idea from the beginning. Something is moving there. And this movement isn't necessarily a creature swimming, but something perhaps more fundamental. Proof that Europa is an active world, geologically alive, right now. One of the strongest clues came from the Hubble telescope. Several times, astronomers have seen what appear to be giant plumes of water vapor being spewed into space, like a cosmic geyser hundreds of miles high. This suggests there are cracks in the ice that go all the way to the ocean. The liquid water down there is being literally launched into space. Another clue is on the surface itself. Recent data from the Juno probe suggests that Europa's entire ice crust might be floating and sliding freely over the ocean. It's as if the moon's shell were loose, moving independently from the core. The entire world is, literally, in motion. And all this activity is the key to everything. It means the chemicals that arrive on the surface with comets can be carried to the ocean, and nutrients from the ocean floor can rise up. It's a global recycling system, a constant cycle that mixes the ingredients and distributes energy. To answer all this, NASA launched one of its boldest missions, the Europa Clipper. Launched in 2024, it's already on its way to Jupiter and will arrive there in 2030. The Clipper won't land. Instead, it will make dozens of low flybys, some at just 15 miles from the surface. With radar that sees through ice, instruments to smell the chemistry, and ultra-high-resolution cameras, it will map the ice thickness, confirm the ocean's depth, and coolest of all, if it's lucky enough to encounter one of those plumes, it will fly through it to taste the ocean water directly. And it won't be alone. The JUICE mission from the European Space Agency is also in the area to study Jupiter and its moons. For the first time in history, we'll have a fleet of robotic detectives investigating this world up close. We're about to begin a new chapter of space exploration. Europa has stopped being just a bright dot in the sky. Now, it's an ocean world with all the ingredients that here on Earth gave rise to life. We have the water, we have the chemistry, we have the energy. The question is no longer if life is possible there, but whether it really sprouted in those dark depths and is still there, waiting for us. The answer, whatever it may be, will forever change our place in the universe. We're not just looking for microbes, we're seeking the answer to humanity's oldest question. Are we alone? And you? After hearing all this, what's your bet? Will we find life in Europa? Is there an ecosystem hidden beneath the ice, or is it just a giant, dark, and lonely ocean? Leave your theory here in the comments. Let's start this conversation. And if you, like us, are passionate about unraveling the universe's great mysteries, go ahead and like, subscribe to the channel, and hit the bell. That way, you won't miss our next journey into the unknown.